Hi everyone, a warm welcome to the topic formation of partial differential equation. Partial differential equations are those equations which contain partial derivatives. Here our assumption is z as a function of x and y, that is z equal to f of x, y. So we can differentiate z partially with respect to x and y. So the corresponding first order partial derivatives are dou z by dou x and dou z by dou y. Also, the second order partial derivatives are dou square z by dou x square, dou square z by dou y dou x. Also, you have to notice that this is also equal to dou square z by dou x dou y. Also, we have dou square z by dou y square. We adopt the notations P equal to dou z by dou x, Q equal to dou z by dou y, R equal to dou square z by dou x square, S equal to dou square z by dou y dou x. It's also same as dou square z by dou x dou y. T equal to dou square z by dou y square. Partial differential equations can be formed either by eliminating arbitrary constants or by eliminating arbitrary functions. In this video, I am going to illustrate how to make partial differential equation by elimination of arbitrary constants. This method is illustrated through the following examples. Let me start.
Form a partial differential equation from z equal to ax plus by plus a square plus b square. See clearly z is a function of x and y. In this set, the arbitrary constants are a and b. By eliminating the arbitrary constants a and b, we can make a partial differential equation from this set. Let me make a partial differential equation from this set by eliminating a and b. For that, you differentiate one partially with respect to x. So we have dou z by dou x, that is p is equal to a. While differentiating partially with respect to x, we have to keep all other variables are constants. So the only variable is x, so the derivative is a. Next you differentiate partially with respect to y. What is left side? It is q. Q is equal to b. So now what is a? A is p and b is q. You put the values of a and b in equation number 1. Then we have z equal to px plus qy plus p square plus q square. See here, z is an equation containing the partial derivatives p and q. So it is the required partial differential equation. Here z is given as z equal to ax plus a square y square plus b. We have to form a partial differential equation. Here a and b are the arbitrary constants. We can make a partial differential equation by eliminating the arbitrary constants a and b. Let it be equation number 1. Differentiate 1 partially with respect to x. So it is left side is p. P is equal to a. Again differentiate 1 partially with respect to y. That is left side, it is q. Q is equal to 2a square y. So we have to make an equation which contains partial derivatives and which are independent of the arbitrary constants a and b. See, by looking into equations 2 and 3, you can make a partial differential equation. See, what is a? A is p. So you put in equation number 3, you can see q is equal to 2p square y. See, it is an equation containing partial derivatives p and q and which does not contain the arbitrary constants a and b. So this is a partial differential equation formed from the given this set. Next, we have to make a partial differential equation from 2z equal to x square by a plus y square by b. For that, first you differentiate z partially with respect to x and y. Then you try to eliminate the arbitrary constants a and b. So differentiating 1 partially with respect to x and y respectively. So what is left side? It is 2p is equal to 2x by a. Again, while differentiating with respect to y, left side is 2q is equal to right side is 2y by b. Suppose this is equation number 2 and it is number 3. We have to make an equation which contains the partial derivatives, and at the same time that equation must be independent of a and b. So from equation number 2, the arbitrary constant a is given by 2x by 2p, that is x by p. Again from equation number b, the arbitrary constant b is given by 2y by 2q, that is y by q. Now we have the arbitrary constants a and b. So put in equation number 1, that is 2z is equal to x square by x by p plus y square by y by q. That is px square by x plus qy square by y. That is equal to px plus qy. What is its left side? It is 2z. See, it is an equation containing the partial derivatives p and q and which is free from the arbitrary constants a and b. So that is a required partial differential equation from the given z. Here we have to make a partial differential equation from z equal to xy plus y into root x square minus a square plus b. Here the arbitrary constants are a and b. You differentiate partially with respect to x and y. Then you try to eliminate a and b. See, this is the method. For that, let it be equation number 1. You differentiate 1 partially with respect to x and y respectively. While differentiating with respect to x, left side is dou z by dou x, that is p. P is equal to y plus y into 1 by 2 root x square minus a square into 2x. That is p is equal to y plus xy by root x square minus a square. Next you differentiate 1 partially with respect to y. So q is equal to x plus root x square minus a square. Let it be equation number 2 and 3. Then if you can eliminate the arbitrary constants, here arbitrary constants are a and b. You try to find a partial differential equation which is independent of a and b. So you try to eliminate a and b. See, from equation number 3, what is root x square minus a square? It is q minus x. You put this root x square minus x square in equation number 2, then you can see it is an equation with the partial derivatives and which is free from a and b. So you put root x square minus a square equal to q minus x in equation number 2. So y plus xy by q minus x. See, it is an equation containing the partial derivatives p and q and which is free from the arbitrary constants a and b. So it is the required partial differential equation from the given set. So this is the equation. Again you can make simplification. It's not necessary. Let me simplify. For that you take q minus x LCM here. So y into q minus x plus xy. That is p into q minus x is equal to y into q minus x plus xy. It is pq minus px equal to yq minus xy plus xy. You can see this will cancel each other. And it is pq is equal to px plus qy. So px plus qy is equal to pq or minus pq equal to 0. See, the simplification is not necessary. Form a partial differential equation from z equal to ax e raised to y plus half a square e raised to 2y plus b. Here the arbitrary constants are a and b. For getting a partial differential equation, first you differentiate partially with respect to x and y. Let be equation number 1. Differentiate 1 partially with respect to x and y respectively. So what is said when equation number 1 is differentiated partially with respect to x? It is p. P is equal to. Here we are differentiating with respect to x, so its derivative is a e raised to y. Only this term contains x, so there is the derivative is a e raised to y. Next, you differentiate partially with respect to y. What is its left side? It is q. Ax into derivative of e raised to y is e raised to y itself. Half a square e raised to 2y into 2. That is q is equal to ax e raised to y plus a square e raised to 2y. Here 2 will cancel each other. Next, you try to think an equation which is free from the arbitrary constants a and b. Here what is a e raised to y? A e raised to y is p. You put a e raised to y as p in this equation. Then you can see it is an equation which is independent of a and b. So you put equation number 2 in 3. So q is equal to a e raised to y is p plus, so a square e raised to 2y is p square. See, it is an equation with the partial derivatives p and q. See, an equation which contains at least one partial derivative is a partial differential equation. Here, both p and q are occurring in the equation. See, it's a partial differential equation, and the arbitrary constants a and b are now eliminated. So, this is the required partial differential equation. Form a partial differential equation from z equal to ax square plus bxy plus cy square. See, this is very different from all the previous z's because here z contains 3 arbitrary constants a, b and c. So, for making a partial differential equation, we have to eliminate these 3 arbitrary constants. Let me make a partial differential equation from z. Differentiate 1 partially with respect to x. What is its left side? It is p is equal to 2ax plus by. Next, differentiate partially with respect to y. We have q is equal to bx plus 2cy. See, here there are 3 arbitrary constants, so we need at least 3 partial derivatives. Usually, we need at least 3 partial derivatives. So, again, you differentiate 2 partially with respect to, here 1 partially with respect to x, this is 1 partially with respect to x. Next, you consider the equation number 2 and you differentiate partially with respect to x again. That is, see, it is dou z by dou x. So, dou square z by dou x square is equal to 2a. See, our notations are our partial derivatives dou z by dou x, dou z by dou y, dou square z by dou x square, dou square z by dou x dou y, dou square z by dou y square. And its notations are p, q, r, s and t. So dou square z by dou x square is r. That is r is equal to 2a. Equation number 4. Next, to differentiate 2 partially with respect to y. We have, see, this is also same as dou square z by dou y dou x. Both derivatives are same. So, let's say it is s is equal to, we are differentiating 2 partially with respect to y. So, s is equal to b. That is equation number 5. See, from equation 4 we have the value of a and from 5 we will get the value of b. Next we have to find the value of c. So again you differentiate 3 partially with respect to what? With respect to y. We have t is equal to 2z. So from 4, 5, 6 we will get the values of a, b and c. From 4, what is a? A is equal to r by 2. From 5, b is s. from 6, C is t by 2. You put these values in equation number 1. So we have z equal to r by 2x square plus s6y plus ty square by 2. See, this is an equation containing the partial derivatives r, s and t, and which is free from a, b, c. So this is the required partial differential equation from z. Let me answer one more interesting question. The question is, form a partial differential equation where x minus a the whole square plus y minus b the whole square equal to z square into cot square alpha. Here the arbitrary constants are a and b. See, this question is entirely different from the previous questions. See, in the previous questions we have z. Here x minus a the whole square plus y minus b the whole square equal to z square into cot square alpha. See, in all the questions, first you differentiate partially with respect to x, then partially with respect to y. Here, you just listen how to differentiate this expression partially with respect to x. So, I am differentiating equation number 1 partially with respect to x. 2 into x minus a. Here, there is no x, so its derivative is 0. Is equal to 2. See, z is a function of x and y. So z contains x. So its derivative is 2z into dou z by dou x. Cot square alpha. See, cot square alpha is a constant. See, here you should be very careful. Most of the students make some mistake there. Some students may think z is a constant, so its derivative is 0. But that's not correct. See, in partial differential equations, our assumption is z is a function of x and y. So z contains both x and y. So its derivative is 2z into derivative of z with respect to x, because we are differentiating partially with respect to x. So you have to multiply by dou z by dou x. What is dou z by dou x? It is our p. That is, you can remove 2. So x minus a is equal to p z cot square alpha. See, this is our x minus a. Similarly, you differentiate 1 partially with respect to y. We have this term is free from y. See, here z is a function of x and y. So z is a dependent variable and it depends on x and y. That's why z contains x and y. But x and y are independent variables. That is, there is no connection between x and y. So here, in the first term, there is no y. So its derivative is 0. Next, derivative of second term is 2 into y minus b is equal to, see, z contains y. So you have to write its derivative. It is 2z. Next, you have to multiply its derivative with respect to y. That is our dou z by dou y into cot square alpha. It's a constant. You remove z. That is y minus b is equal to, see, this is our q. So q into z cot square alpha. So we are trying to eliminate a and b. So now you can easily eliminate a and b by substituting x minus a and y minus b in this equation. So put x minus a and y minus b in equation number 1. So equation number 1 implies, what is x minus a? This much. That is p square is z square cot raised to 4 alpha plus q square is z square cot raised to 4 alpha is equal to z square cot square alpha. See, you can see z square is common. You can remove it. So it is, and again you can remove a cot square alpha. So it is p square cot square alpha plus q square cot square alpha is equal to 1. You take cot square alpha common outside. P square plus q square is equal to 1. See, it is an equation containing the partial derivatives p and q. So it must contain at least one partial derivative. Here, fortunately, it contains both partial derivatives. It's not compulsory for both p and q. So it is an equation which contains partial derivatives. So it is a partial differential equation, and that's our required partial differential equation from